In this video, we will try to solve as many questions as possible that were asked in GM Economics paper of 2022. The first question is like this. When the supply curve is Sx, this very curve, this green curve, is backward bending, and the demand curve, which is this black line, dx, is downward sloping as shown in figure. There are two equilibria. Okay, so we have two equilibria points M and N. Okay, equilibrium occurs when demand and supply uh, curves intersect. Okay, so we have two intersection points here. Which of these statements is correct? Okay, we are being given four options and we need to see which of the option is correct. First option is tells us only M is stable equilibrium. This point M is the stable equilibrium, N is a stable equilibrium. Both M and N are stable equilibria, or both M and N are unstable equilibria. Okay, before we try to figure out which of the option is correct, we should know about what is meant by stable equilibrium and what is meant by unstable equilibrium. Okay, so simple thing, stable equilibrium is that type of equilibrium where any disturbance in the equilibrium situation is self-adjusting so that the old equilibrium position is restored. Okay, so if we try to draw the graph of a stable equilibrium position, so we will have what we call as we have the usual downward sloping demand curve, okay, and upward sloping supply curve. Okay, so what I told you, stable equilibrium is that type of equilibrium where any disturbance in this equilibrium situation is self-adjusting. That means so that old equilibrium position is restored. Okay, what is meant by, let us say the let us say this was our original price. Okay, any deviation from this equilibrium position, let us say price decreases to P2. Okay, now here you can see quantity supplied is this stuff and quantity demanded is this very stuff. So here we have excess demand. Okay, when we have excess demand, obviously there will be competition among buyers and the price will go up. Okay, so we will go back to the original position. Okay, so any deviation from old equilibrium will lead us to back to the old equilibrium. Okay, similarly, if price increases, let us say we have price P2 here. Okay, here we can see demand is less, supply is more. Okay, so when there is more supply, obviously producers will try to lower the price so that they clear all their inventories. Okay, so when we have excess supply, producers will lower the price and we are back to the original equilibrium. Okay, this is the concept of stable equilibrium. That is, it is a type of equilibrium where any disturbance of the equilibrium situation is self-adjusting. Okay, so if price goes down, okay, we have excess demand. So when we have excess demand, price will go up till we reach back to the original equilibrium. And if price goes up, there is excess supply, so suppliers will lower their prices and we will reach back to the original equilibrium. This is the concept of a stable equilibrium. So any deviation, you can think it like this. So if we have this very bowl shaped container and we put a ball here. Okay, so if this ball is being disturbed, so it will go up down, but it will rest at this point. Okay, so we say this is the stable equilibrium. Now let us see what is meant by unstable equilibrium. Okay, equilibrium is said to be unstable when any disturbance in equilibrium situation brings in forces which move the system away from it and never to be restored. Okay, so any deviation from the old equilibrium, if it does not lead us back to the old equilibrium, we say the equilibrium is unstable. Okay, so let's cut it short and explain it with the help of diagram. In case of unstable equilibrium, what we have negative slope demand curve, okay, which is obvious, which is normal thing. But we have also negative sloped supply curve, okay. So we have negative sloped supply curve also. Let us say this is the equilibrium position, okay. So we say equilibrium is stable if any deviation from the old equilibrium leads us back to the old equilibrium, okay. So market forces interact in such a way that we are forced to reach to the old equilibrium, then we say it is stable. But unstable in the sense, if any deviation from this point, okay, if there is any deviation, if we are not able to go back to the original equilibrium, we say the equilibrium is unstable, okay. Let us say we have price P here, okay. Let us say for any reason price goes down, okay. So price goes down. Here we can see demand is less, supply is more, okay. So this is our supply curve, this is demand curve, okay. When supply is more and demand is less, what will happen? Suppliers will try to decrease their prices, okay. So prices will go further down, okay. So we will go further down, okay. Here we have also demand less, supply more, and suppliers will try to move the prices lower, okay. So we are moving this way, okay. We will not be able to reach to this point. In this case we say we have unstable equilibrium, okay. So we are getting away from this old equilibrium, okay. So let us draw it somewhat straight like this, okay, to make sense here. Let us say if price goes up, let us say we have price of P2 here, okay. Let us say we have P2, here we have P1, okay. If for any reasons price goes up, okay, here we can see this much is our supply, this much is our demand. Here supply is less, demand is more. When demand is more, supply is less, price will go up, okay. So we will move away from this point, okay. Remember this thing, we are not able to reach to this point as we were able in this diagram. So we are moving away from the old equilibrium, okay. Any deviation from the old equilibrium does not lead us back to the old equilibrium, okay. So we say equilibrium is unstable, okay. So let us draw it much clear here, okay. So I was not able to show it properly, so let us try to do another attempt. So we have this demand curve, this is our demand curve. Let us say this is our supply curve, okay. So originally we are at this point, okay. Let us say this is P, this is our supply, okay. So if price goes down to P1, here you can see demand is less, supply is more. When supply is greater than demand, price will get down, okay. So we will move away to new position. Let us say price goes down to P2. Again here we can see demand is less, supply is more, okay. Prices will further go down and we will not be able to reach this point. We are going away from the old equilibrium, okay. Similarly, if price is, so let us draw it somewhat straight for the sake of simplicity here, okay. So here same case is, if price increases, if price increases to let us say P4, okay. Here we can see supply is less, demand is more. If supply is less, demand is more, price will increase, okay. So we will go up again at this point. Supply is less, demand is more. When demand is greater than supply, price will further increase, okay. So we are not able to reach back to the original equilibrium. In this case we say we have unstable equilibrium, okay. So if we break this figure here, you can see, if I break this figure here, so we have this negative sloped supply curve, and negative slope demand curve. Okay, so we have this situation. Okay, so this point will be unstable. Okay, because we have supply and demand both negatively sloped. Okay, and let us say what is this point. You can clearly see this point. If I can draw it here, so let me draw it here. So we have another situation here. In this case, this is our demand curve. Okay, and this is our supply curve. This is our supply curve. Okay, sorry, this is, I'm not able to do it correctly. So it is somewhat like this. We have this supply curve, we have demand curve like this, we have supply curve like this. Okay, so this is our supply curve, this is our demand curve. So we have this very situation, and we can say we have the stable equilibrium at point N. Okay, so we have a positive sloped demand supply curve and negative sloped demand curve. In this case, we will be able to reach to the old equilibrium. Okay, so this figure denotes N point, and this figure denotes the M point. Okay, so if I write here M, this is N, so obviously N is the stable equilibrium. Okay, so the correct option should be only N is stable equilibrium. Next question is, let the production function be Q is equal to under root of L square plus K square. The unit price of labor and capital be rupees 30 and rupees 40 respectively, and total cost be 580 rupees. Then the maximum value of Q subject to the cost constraint is, we have to find the maximum value of Q here subject to the cost constraint. So what we are being given, we have the production function. That means we want to maximize Q is equal to under root of L square plus K square. Okay, this is our objective function. We want to maximize this Q subject to the cost constraint. Okay, how do we write cost constraint? Cost constraint is simply wage rate times number of laborers employed plus rental cost of capital into units of capital employed should be equal to total cost. Okay, now what is the what we call the unit price of labor is 30. So in place of W we have 30 L plus unit price of capital is 40. That means 40 K should be equal to what is total cost of 580. Okay, so we want to maximize Q is equal to this stuff subject to this constraint. Okay, so how do we maximize? Simple thing, what we will do here, we will use the tangency condition. Okay, if I can grab this out here also, let us say this is our iso cost line. Okay, and let us say this is our isocont. Okay, so optimal values of L and K are found where this isocont, okay, isocont is tangent to this isocost. Okay, at this point we have optimal value of labor and capital. Okay, first we need to find the optimal value of L and K and then plug in this objective function to get the maximum value of Q. Okay, so this means here, this stuff means that marginal rate of technical substitution between labor and capital should be equal to the price ratio. That means price of labor upon price of capital. Okay, now price of labor as we are being given here, that is 30. Okay, which is equal to wage rate here. So I can write it like this. So here you can also write PL. So I have written W for the sake of simplicity, and price of capital is being given us as 40. Okay, now using this very stuff here. Now marginal rate of technical substitution means marginal productivity of labor upon marginal productivity of capital should be equal to PL upon PK. Okay, simple thing here. Now what is MPL, marginal product of labor? That means we need to differentiate this production function partially with respect to L. Okay, so if I rewrite this, like I can write this stuff, Q is equal to L square plus K square raised power 1 upon 2. Okay, same thing, nothing happens. I have just changed this under root in terms of power. Okay, now we need to partially differentiate this function with respect to L to get the marginal product of labor. Okay, so MPL is, so differentiating this with respect to L, so this 1 upon 2, this power becomes coefficient, so we have exponent becomes coefficient 1 upon 2, then we have L square plus K square, and this exponent is subtracted by 1 by power function rule, and then we need to internally differentiate this L square. That means we have the derivative of L square is 2L, so this is our MPL divided by MPK. So partially differentiating this production function with respect to capital this time. Okay, same stuff, this power becomes coefficient, so we have 1 upon 1 upon 2 L square plus K square, and this exponent is subtracted by 1, and internally differentiating K square, derivative of K square is 2K. Okay, should be equal to price of labor is 30 upon price of capital is 40. Okay, let us do some cancellation. 1 upon 2, 1 upon 2 gets cancelled, so this whole stuff will get cancelled here. This 2 and 2 will get cancelled here, 0 and 0 gets cancelled. That means L upon K is equal to 3 upon 4, which means L is equal to, if I transpose this, it will get multiplied, so we have 3 upon 4K. Okay, so this is the value of L. Now just plug this value in this cost constraint. Okay, so I can write 30 in place of L. I have this very stuff, that is 3K upon 4. Okay, plus we have this 40K. 40K should be equal to 580, which means so this is this will come out to be 30 into 3 is 90. 90 upon 4 comes out to be 22.5. 22.5 K plus 40K should be equal to 580. So adding these two K's, we will get 62.5. K should be equal to 580, which implies K is equal to 580 upon 62.5, and when we divide we will get 9.28 as the optimal value of K. So we have 9.28 as the value of K. Now to get the value of L, just plug K is equal to this 9.28 again in the cost constraint. Okay, so just plug K is equal to this stuff in cost constraint. So we have 30L, so we have 30L plus 40 in place of K. We have this 9.28. Okay, should be equal to 580, which means we have 30L is equal to 580. This 40 into 9.28, when calculated, this comes out to be 371.2. That means 30L is equal to 208.8, or L is equal to 208.8 dividing this 30, okay, which gives us the optimal value of L as 6.96. okay, so we got the optimal value of L, optimal value of K, so L is equal to 6.96. okay, now what will be the maximum value of Q, sorry. So maximum value of Q is, just plug these optimal values into the objective function. That means our Q will be equal to under root of, so the value of L is 6.96, we have 6.96 square, okay, plus we have this 9.28, that is our K square, 9.28 square, which means we have 48.44, the 6.96 comes out to be this stuff, plus 9.828 square comes out to be 86.12, which gives us 134.56 is the value of K. If we take the root, we have this square root comes out to be 11.6. okay, that means the maximum value of Q will be 11.6. okay, next question is related to national income identity. The question is like this: let the consumption function, tax function, and income identity be given by C is equal to C naught plus B y minus T, where C is the consumption, C naught is the autonomous consumption, B is the marginal propensity to consume, and T is the tax rate, and T is equal to T naught plus Ty. okay, here this T is the marginal tax rate, and our identity, national identity, is being given as Y is equal to C plus I naught plus G naught, where I naught and G naught are the autonomous investment and government expenditure, which is also autonomous. okay, if the marginal propensity to consume is 0.75 and marginal tax rate is 0.1, then increase in autonomous government expenditure by rupees 20 million will lead to increase in income by how many $1 million. We need to find out that very stuff. okay, so what we are being given, we have C is equal to C naught plus B y minus T. okay, also tax is a function of T naught plus marginal tax rate times y, and y is equal to C plus I naught plus G naught. This is our what we call the income identity, or B is equal to 0.75. This is our marginal propensity to consume, and marginal tax rate is 0.1. okay, so how do we solve? Let's write this identity first. So we have C plus I naught plus G naught. okay, now this C, in place of C I have to write this very stuff. okay, this is our consumption expenditure, so, or consumption function. So we have B in place of Y, I can write it as it is. okay, then we have this I naught plus G naught. okay, so I can write it like this: C naught plus B y minus T is equal to this very stuff. okay, so I can write T naught plus Ty plus I naught plus G naught, or we can write it like this: C naught plus B, we have Y minus T naught minus Ty plus I naught plus G naught. okay, so let's give the variables their values. So we have C naught plus MPC is 0.75, 0.75. okay, here we have Y minus T naught minus the marginal tax rate is 0.1, 0.1 Y plus I naught plus G naught. okay, this whole stuff is equal to Y, which means y is equal to c naught plus 0.75. okay, y minus 0.1, y comes out to be 0.9 y, and we have this minus 0.75 t naught here, okay, plus I naught plus g naught. Okay, so we have y is equal to c naught plus, when we multiply this 0.75 with 0.9, we will get 0.675 y. Then we have minus 0.75 t naught plus I naught plus g naught. okay, now transposing this stuff to LHS, that means y minus 0.675 y is equal to c naught plus 0. C naught, we have minus we have minus 0.75 t naught plus I naught plus g naught. When we subtract this stuff, this comes out y minus 0.675 y comes out to be 0.325 y should be equal to this c naught minus 0.75 t naught plus I naught plus g naught. okay, or y is equal to 1 upon, if I transpose this, it will get divided, so I will write 0.325. okay, then we have c naught minus 0.75 t naught plus I naught plus g naught. okay, now what we are being told, what happens if g naught increases by 20 million, what will happen to our income? That means we need to take the partial derivative of this function with respect to g naught. okay, that means change in income with respect to change in government expenditure. okay, should be equal to, so here we don't have any g naught, its derivative will be 0. Here it will be also 0 because we have no g naught here. This will be also equal to 0. Here the derivative of g naught is 1, so we are left with 1 into 1 is 1, so we are left 1 upon 0.325. okay, now change in government expenditure is being given us, that is by 20 million. That means del y upon del g naught is our 20, should be equal to 1 upon 0.325, which implies our change in income will be equal to, if I transpose this, it will get multiplied, so we have 20 upon 0.325. that means our income will increase by 61.54 million rupees. okay, when government expenditure increases by 20 million, income will increase by 61 point. Let the system of equations be alpha u plus w is equal to 0, u plus alpha v is equal to 0, and v plus alpha w is equal to 0, where alpha belongs to real numbers. Then the system has infinite solutions. If alpha is equal to, we have to find the value of alpha here, for which this system of equations has infinite solutions. okay, so let us write these equations first. So we have alpha u, so we have alpha u plus, in place of v, I can write here 0v plus w is equal to 0. okay, so 0 times v is 0, so we are left with alpha u plus w. Similarly, we have u here, u plus alpha v plus, in place of 0 I can write 0 times w is equal to 0. Similarly, we have last equation, so in place of, since we have no u in this equation, so in place of this I can write 0 times u plus v plus alpha w, okay, is equal to 0. So what will we do? We will write the system of equations in matrix form and use Cramer's rule in finding whether the value of alpha, so that this system of equation has infinite solutions. Okay, so writing them in matrix form means we write it like this: a x is equal to b, okay, where this a is the coefficient matrix. So I will write here our a is equal to the coefficient of u, v and w. So here the coefficient of u is alpha. I can write here alpha. Here we have 1, the coefficient of u. Here we have 0. Okay, here we have the coefficient of v as 0. Here we have alpha. Here we have v, in place of v, the coefficient is 1. Okay, here the coefficient of w is 1. Here we have 0. Okay, this is our coefficient matrix. And what is our x? X is the solution vector. That means what we need to find u, v, w. Okay, u, v, w. And our b is the vector of constant terms. Okay, b is our vector of constant terms. Here we have 0, 0, 0. Okay, so first thing is to write the system of equations in matrix form. Now this system of equations will have infinite solution if, okay, if so I will write this system of equations have infinite solutions if the determinant of this coefficient matrix, that means if our the determinant of this coefficient matrix is equal to 0, and the other matrices, that means a1 is equal to a2 is equal to a3. If these are also equal to 0, then we say the system has infinite solutions. Okay, now what are these a1, a2 and a3? These are the matrices which are formed by replacing the column of this coefficient matrix with the vector of constant terms. Okay, so we don't need to find them here, but this is the condition for the infinite solutions. Okay, so if I have time, I will show you how do we get a1, a2 and a3. First, let us see, if determinant is equal to 0, then we will have infinite solutions. That means, so taking determinant of this matrix, that means first we have alpha. So I will write here alpha. Okay, now mentally deleting this row and this column and taking determinant of the remaining elements. That means alpha into alpha is alpha square, minus 1 into 0 is 0. Then we write minus times 0. Okay, so first we have plus, then minus, then plus. Okay, so this is from the formula. So now deleting this row and this column and taking determinant of remaining elements, that means 1, 0, 0 alpha. 1 into alpha is alpha, minus 0 into 0 is 0. Okay, then we have plus 1. Okay, now in this here what we need to do, we need to delete this row and this column and take the determinant of the remaining elements. That means 1 into 1 is 1, minus 0 into alpha is 0. Okay, actually I have explained this whole stuff in the matrices series, in linear algebra series. You can find out how do we use the Cramer's rule or how to find the determinant. Okay, so this whole step should be equal to 0. Now here you can see we have alpha into alpha square. This means this is alpha cube. Okay, then since this 0 is multiplied to this term, this whole stuff will become 0. Here we have 1 into 1 is 1. That means alpha cube plus 1 should be equal to 0. Okay, that implies, so we have alpha cube plus 1 is equal to 0. We can write it like this: alpha plus 1, this is the formula. How do we write? Then we have alpha square minus alpha plus 1 should be equal to 0. Okay, I am just expanding this here because we have a cube, or I can write it like this: x cube plus 1 is always equal to x plus 1. This is the formula which I guess you know. This is the basic formula. So this is equal to x square minus x plus 1. Okay, so this straightforward comes from the formula, okay, from the factorization. So here either this stuff is equal to 0 or this stuff is equal to 0. Okay, so let us write alpha plus 1 is equal to 0, or this stuff alpha square minus alpha plus 1 is equal to 0. If alpha plus 1 is equal to 0, that means alpha is equal to minus 1. Okay, if this stuff is equal to 0, then this is a quadratic function. We can use the quadratic formula to get the value of alpha here. And what is the quadratic formula? Let's write here. The coefficient of alpha is here 1, so a, let us say we have b is minus 1, a is equal to 1, and c, in place of c we have 1. Using the quadratic formula, that means alpha will be equal to minus b plus minus b square minus 4ac divided by 2a. Okay, so what is our minus, what is b? B is equal to minus 1, so we have minus, then we have minus 1 plus minus b square means minus 1 square minus 4, value of a is 1 and c is also equal to 1, so we have like this, then twice a, that means 2 into 1. So this comes out to be minus minus is plus, we get 1 plus minus minus 1 square is 1 minus 4 upon 2, which implies we have 1 plus 1 minus 4 is under root 3 minus under root 3 upon 2, or we have another value, that is 1 minus minus 3 upon 2. Okay, so here we can write it 1. Since we have minus under root, this can be written like this. We have iota here, under root 3 upon 2, and here we have 1 minus, so we have iota under root 3 upon 2. Okay, so we got three values for alpha. Alpha is equal to minus 1, and alpha is equal to this stuff. Okay, and alpha is equal to this stuff. We got three values for alpha. Okay, here you can see these are the imaginary values here, and we only get one real what you call real value for the alpha. That means the answer to this question should be equal to minus 1, because we are being told the answer should be an integer. Only this very alpha is equal to minus 1 is integer. These are the imaginary numbers here. Okay, so how do we write this minus iota? We know that minus under root 3 can be written like this, minus 1 into 3, so we have under root minus 1 into under root 3, and under root minus 1 is always equal to iota under root 3. Okay, so we got the value of alpha is equal to minus 1. Okay, another point that I want to make here is that the determinant of these matrices should be equal to 0. How do we find out these determinants, these matrices? It is simple. So let me show you what is our A1. A1 is our special matrix, which is formed by replacing the first column of this coefficient matrix with the vector of constant terms. So in place of alpha 1 0, we write 0 0 1. That means we have 0 0 0, then we have 0 alpha 1 0 alpha 1, then we have 1 0 alpha. If you want to take the determinant, it will be also equal to 0. Similarly, A2 is our another special matrix, which is formed by replacing second column of this coefficient matrix with the vector of constant terms. So we have alpha 1 0 alpha 1 0. In place of 0 alpha 1 we have 0 0 0 0 0 0, and this stuff remains same 1 0 alpha. Okay, similarly its determinant will be also equal to 0, and our a3 is equal to, now the a3, this matrix is formed by replacing third column of this coefficient matrix with the vector of constant terms. So we have alpha 1 0 as it is, alpha 1 0, then we have 0 alpha 1, and in place of 1 0 alpha we replace it by the vector of constant terms, which is 0 0 0. If you take the determinant of these elements, these matrices, it will be equal to 0. Okay, so the system of equations will have infinite solution if our coefficient matrix, the determinant of the coefficient matrix is 0, and the determinant of these special matrices is also equal to 0. If any of these matrices has non-zero determinant, in this case we would have no solution. Let us say if the determinant of this a1 came out to be a non-zero number, then we could have said the system of equations would have what we call no solution. Okay, when coefficient matrix, the determinant of the coefficient matrix is 0 and the determinant of the special matrix is also 0, then we say the system of equations has infinite solution. So the value of alpha is -1. Which of the following statements is correct for game A and game B? The statements are regarding Nash equilibrium. So let us try to find out the Nash equilibrium for game A first and then for game B. Okay, so for that let me zoom this out. Okay, now we have two players, Mary and John. Okay, now let us see what happens if Mary chooses to go for movie. In this case, John has two options, either to go for movie or to go for football. Movie gives him 1 as payoff, football gives him 0 as payoff. Obviously 1 is greater than 0, so John will choose to go for movie. Okay, so for that let me rub this out here. Okay, now let us see what happens if Mary goes for football. Again John has two options, either to go for movie or to go for football. Movie gives him 0 as payoff, football gives him 2 as payoff. Obviously 2 is greater than 0, so John will choose to go for football. Okay, so for that let me rub this out here and rub this whole stuff here. Okay, now let us see what happens if John chooses to go for movie. In this case, Mary has two options, either to go for movie or to go for football. Movie gives her 2 as payoff, and football gives her 0 as payoff. Obviously 2 is greater than 0, so Mary will choose to go for movie. For that let us rub this out. Okay, now let us see if John chooses to go for football. Again Mary has two options, either to go for movie or to go for football. Movie gives her 0 as payoff, football gives her 1 as payoff. Obviously 1 is greater than 0, so Mary will choose to go for football. Okay, so what we have here, we can clearly see we have two numbers being underlined in two cells. So these two numbers to denote the Nash equilibrium. So Nash equilibrium in this case is movie and football. So we have two Nash equilibrium for game A. Okay, now let us see game second. So in this case we have convex 1 and convex 2. Okay, let us see what happens if convex 1 do not confess. Okay, in this case convex 2 has two options, either do not confess or to confess. Do not confess gives him -1 as payoff. To confess he gets 0 as payoff. Obviously convex 2 will choose 0 because 0 is greater than -1, so convex 2 will choose to confess here. Okay, so let us rub this out here. Now let us see what happens if convict 1 chooses to confess. Again, convict 2 has two options, either do not confess or to confess. Here you can see do not confess gives him -1 is payoff, -9 is payoff, sorry, and to confess he gets -5 is payoff. Obviously -5 is greater than -9, then convict 2 will choose to confess here. Okay, so let us rub this out here. Now let us see what happens if convict 2 chooses do not confess. In this case, convict 1 has two options, either do not confess or to confess. And obviously you can see here do not confess gives him -1 as payoff, and to confess he gets 0 as payoff. Here you can see 0 is greater than -1, so convict 1 will choose to confess here. Okay, so let us rub this out here. Now let us see what happens if convict 2 chooses to confess. Okay, so in this case again convict 1 has two options, either do not confess or to confess. Again, do not confess gives him -9 as payoff, and to confess he gets -5 as payoff. Obviously -5 is greater than -9, so convict 1 will choose to confess. Okay, let us rub this here. Okay, here you can see only one cell is there where both numbers are underlined. Okay, so we can say this game has only one Nash equilibrium, that is confess and confess. Okay, so what are the statements being given us? Let us try to see. So these are the statements, and we got for first game we got for game A we got movie and football is Nash equilibrium, and for game B we got confess, and confess is Nash equilibrium. Okay, here you can see only only D option satisfies both the conditions. That is, in game A both movie and football represent Nash equilibrium, and in game B the Nash equilibrium is confess. Okay, I hope. Next question is, suppose that per capita GDP of India and USA are growing at annual average rates of 8.8% and 1.8% respectively. Further, consider that in 2019-20 per capita GDP of USA was $41,099 dollars, and that of India was $1,570. Okay, assuming that the two countries continue to grow at the above rates, we assume that they will grow with the given rates, that is 8.8% at 1.8%. Okay, then India's per capita GDP will be equal to per capita GDP of USA in how many years? That means in how many years will be the per capita GDP of India equal to the per capita GDP of America. Okay, so how do we solve this question? Let us see what is the USA. We are being given the growth rate of USA is 1.8%. Okay, and per capita, so let me write here, per capita GDP or income of USA is being given as 41099. Okay, and similarly for India, we are being given as growth rate is 8.8%, 8.8%, and per capita GDP or per capita income is equal to $1,570. We need to see after how many years will be the per capita of India equal to the per capita of USA. Okay, so for that what will we write? Let us say after n years. Okay, let us say after n years per capita income of USA is equal to per capita income of India. Okay, so I'm just assuming after n years their per capita income will be equal. Okay, assuming that they grow at 8.8 at 1.8 percent annually. Okay, now so after n years what will be the per capita of USA? Simple thing. So per, let me write it here, per capita income of USA after n years will be equal to, so let me write, that is equal to 41099. That is our original amount. To this we multiply 1 plus 0.018, okay, raised power n. Okay, after n years per capita income of USA will be equal to this very stuff. Okay, so this is the growth equation, growth formula, which we use in the compound interest rate also. Okay, so this is our what we call principal amount. Okay, this is the number of years, this denotes the growth rate. Okay, similarly for India, what will be the per capita income? Per capita income after n years will be equal to, so we have here 1570. That is our original amount, or in this case original per capita income. To this we multiply 1 plus the growth rate of India is being given as 8.8%. When we write it in terms of decimals, this will be equal to 0.088. Okay, raise power n. Okay, so we are assuming that after n years their per capita income will be equal to. That means we can just equate these two equations. That means how can I write it? Like per capita income of USA after n years, okay, will be equal to per capita income of India. Okay, that means this is our per capita income of USA after n years. So we write 41099. So if we add up this step, this comes out to be 1.088 phrase power n should be equal to per capita income of India after n years, that is 1570. And if we add these two, sorry, I have done a mistake here. This is 0 point, sorry, 1.018, 1.018. Okay, so here we have 1 plus sorry, let me add up this one and this decimal portion. This comes out to be 1.088 raised power n here. Okay, now just transpose this term to LHS. So we have 41099 upon 1570, and transposing this term to RHS. Okay, so we have 1.088 raised power n divided by 1.018 raised power n. Okay, and this can be written like this. So if we divide this stuff, this will come out to be 26.178 should be equal to, and here it can be written like this, 1.088 upon 1.018 whole raised power n. Okay, so if we divide this stuff, so we have 1.069 raised power n is equal to 26.178. Okay, now we take a log on both sides. That means this n will become coefficient, so we have n log 1.069 is equal to log of 26.178. okay, which comes out to be, we have n here, log of this 1.069 comes out to be 0.029. okay, and log of 26.178, it comes out to be 1.418. okay, that means our n will be equal to 1.418 upon 0.029, which comes out to be 48.89. okay, if we divide this stuff we will get 48.89. that means after a 48.89 years, per capita GDP of India will be equal to the per capita GDP of USA. okay, this given the following information related to product and money market. We are being given the product market and money market. In product market, our consumption function is equal to 300 plus 0.8 y minus t. This 0.8 is our marginal propensity to consume, y is the income, and t is the tax. T is equal to 200 plus 0.2 y, where t is the tax and 0.2 denotes our marginal tax rate. Autonomous investment is 300. Government expenditure, which is also autonomous here, is 400. In the money market side, we have m naught upon p is equal to 0.4 y minus 200 I, where m naught denotes the what we call the nominal money supply, which is 900. Price is one which is fixed. That means this m naught upon p denotes our real money supply. okay, and I is the interest rate. We are being told to find the equilibrium level of interest rate. okay, so let's solve first product market. okay, in the product market we are being given or I will say write it like this. In the product market we have our national income identity like this: y is equal to c plus I plus g. okay, to solve for the product market we use this income identity. So for that we have consumption function is 300 plus 0.8 we have y minus t, plus we have this investment is autonomous here, which is 300. okay, plus government expenditure is 400. so we can write it like this: 300 plus 0.8 we have y minus the value of t is this 200 plus 0.2y plus 300 plus 400. okay, or we can write it like this: 4 7 10 we have 1000. okay, plus 0.8 here. If we subtract y, or I can write it like this: y minus 0, sorry, we have 200 here, so we have 200 minus 0.2 y, or we can write it like this: we have 1000 plus 0.8. now y minus 0.2 y comes out to be 0.8 y minus 200, or we can write it like this: we have 1000 plus 0.8 into 0.8 y, multiplying this 0.8 to this term first, then we have minus 0.8 into 200 obviously. okay, we can write it like this. so we have here 1000 0.8 into 0.8 comes out to be 0 let me write 0.64 y, and here we have 0.8 of 200, this comes out to be 160. that means if I transpose this term to this LHS, so we have y minus 0.64 y is equal to 1000 minus 160, this comes out to be 840. okay, so if we subtract 0.64 y from y, we will get 0.36 y is equal to this 840, or y is equal to 840 upon 0.36, which gives us the equilibrium level of income is 233.3, sorry, we have another 3.33. this is our equilibrium level of income. Okay, but we need to find out the equilibrium level of interest rate. Okay, so we have here this real money supply m naught upon p means we have 900 upon 1. So in this case we have money supply should be equal to money demand. Okay, so this denotes our money supply, which is real, and this denotes our money demand. Okay, so money market equilibrium requires that our money supply should be equal to money demand. So for that, what we need to do, we just equate these two things here and insert the value of equilibrium level of income. Okay, m naught upon p is 900 upon 1, so I can write here 900 upon 1 is equal to 0.4. The equilibrium level of y, which we got here, 2333.33 minus 200 I. Okay, so we have here 900 is equal to, now what we need to do here, we just multiply this 0.4 to this 2333, which comes out to be 933.33 minus 200 I. Okay, after that what we need to do, just transpose this term to LHS, so this becomes positive. We have 200 I is equal to 933.33, and transposing this to RHS, it gets subtracted, or 200 I is equal to, when subtracting, this comes out to be 33.33, which means our I will be equal to 33.33 upon 200. Okay, when we divide, this stuff comes out to be, let me write it here, it comes out to be 0.166666. Okay, so this is our equilibrium level of interest, but we need to write this very stuff in percentage form. Okay, so how can we write it? So this is in decimal. If we change it into percentage, this will become 16.66%. Okay, so the equilibrium level of interest rate should be equal to 16.66. The question is like this: let the linear programming problem be maximize z is equal to minus 0.2 x1 plus x2 subject to the constraints 2x1 plus 5x2 is less or equal to 70, x1 plus x2 is less or equal to 20, x1 and x2 are greater or equal to 0. If x1 is equal to a, x2 is equal to b is the optimal solution, then what is the value of x plus b? Okay, we have to find out the solution of this very question. That means sum of the x1 plus x2, which are the optimal solutions. Okay, how do we solve this question? So let's take these inequalities and change them into equalities. Okay, so we have 2x1 plus 5x2 is equal to 70. Okay, first step is to change the inequalities into equalities. Now we will also graph this out. Okay, so we will graph this. Let us put x1 is equal to 0. If we put x1 is equal to 0, our x2 will be equal to, if this stuff is 0, so x2 will be 70 upon 5. So this is 70 upon 5 is 5 ones are 5, 6 is 7, 5 fours are 20. Okay, then put x2 is equal to 0. Okay, now in secondly we put x2 is equal to 0, so this whole stuff becomes 0. That means x1 is equal to 70 upon 2, that is 35. That means x1 is equal to 35. Okay, so let's graph these two pointers here. So the pointers here are 0, 14, and here we have 35, 0. Okay, so let's graph this out here. So we have 0, 14. Let us say this point is denotes our 14. Okay, and we have 35 0. Okay, let us say this is our 35 0. This will be the line for this 2x1 plus 5x2 is equal to 70. Now take another x1 plus x2, x1 plus x2, change this inequality into equality, is equal to 0, sorry, is equal to 20. Similar procedure, put firstly x1 is equal to 0. If we put x1 is equal to 0, which implies x2 will be equal to 20. Okay, so 0 plus x2 is equal to 20. Now put x2 is equal to 20, sorry, 0. If we put x2 is equal to 0, which means x1 is equal to 20. Okay, x1 is equal to 20. Okay, so then the pointers will be 0, 20 and 20, 0. Okay, let's graph them also out. So we have 0, 20, that means this will be our 20. This is obviously x1 here. We have x2 on this axis, so we have 20 here. Sorry, we have this point 0, 20. I guess I have drawn this also incorrectly here. Okay, I apologize for these horrendous mistakes. So we have 0, 14, so 14 will be here. First coordinate is also for always for x-axis, and second is for y-axis. Then we have 35. So this is like this. We have 35 here and 14 here. Okay, so secondly we have 20. So let us say this is 20 on this let us say this is the 20, the point 0, 20, then we have 20, 0. So this will look like this. I should have drawn it with another color. Okay, so we have here 20. The coordinates obviously are here 20, 0 here, and the coordinates are 0, 14. Okay, I am just writing them. So the coordinate of this point is 0, 20. So I will write here 0, 20. Okay, now let's try to find out the coordinate of this point. Okay, where these two lines intersect. For that, what we need to do, simply take these two equations. Let us say this is equation first, equation second, solve them for x1 and x2. How can we solve? So if we multiply this equation both sides by 2, so this equation will become 2x1 plus 2x2 is equal to 40. And originally we have this equation 2x1 plus 5x2 is equal to 70. Now subtract them, or we can subtract them here. Okay, so 2x1 minus 2x1 gets cancelled. So 2x2 minus 5x2 comes out to be minus 3x2 minus 40. 40 minus 70 comes out to be minus 30. So negative sign gets cancelled. X2 is equal to 30 upon 3, which means we have 10 as the value of x2. If x2 is equal to 10, okay, then what will be the value of x1? So we have 2x1 plus 5. The value of x2 is 10, so I can write it here 10 is equal to 70, which means 2x1 is equal to 70 minus 50, or x1 is equal to 70 minus 50 is 20 upon 2, which comes out to be 10. So the coordinates of this point are 10 and 10. Okay, and what is our feasible region? Feasible region is that very region which is bounded by these two lines. Okay, so this region, the common region of these two lines, what we call this is the feasible region. Okay, in the feasible region we would have the optimal solution. Okay, what is the feasible region? Feasible region is the region which is bounded by the two lines, which is the common region here. Okay, and since we have x2 x1 plus 5x2 less or equal to 70, so this will lie inside this box here. Okay, if it was greater than 70, then our feasible region would have been upwards. Okay, so this is our feasible region. Now we have 3 points, and at these 3 points we need to find out what will be the maximum possible value of x1 and x2, which gives us the maximum value of z. So what are the points we need to focus on? We have 0, 14, then we have 10, 10, and then we have 20, 0. Okay, just plug these values into our objective function. So what will be our z then? So we have minus 0.2, the value of x1 is, so let us write, this is x1, this is x2. X1 is 0 and x2 is 14. Okay, we are checking at this point. Okay, let me rub this out, and this is 14. So 0 times this negative number is 0, so we get here 14 as the value of z. Let's try to figure out at this point, when x1 is equal to 10, x2 is equal to 10, at this point what will be our z? Just plug, we have minus 0.2 into 10 plus the value of x2 is also 10, so this is minus 2 plus 10, so we only get here 8 as the maximum value of z. On this point, let's plug again. We have minus 0.2 minus 0.2, x1 is 20 plus 0, x2 is 0, so I can write it here. So we have this will be a negative number, it will be minus 4. Okay, from these 3 points, this point, this point, and this point, the maximum value of z occurs at this point. Okay, z is maximum when x1 is equal to 0 and x2 is equal to 14. Okay, then so x1 will be equal to a, x2 is equal to b. That means our x1 is equal to 0, x2 is equal to 14. Okay, so we have 0 plus 14, which will come out to be 14. That means the maximum or optimal solution to this question will be equal to 14, and the optimal values of x1 and x2 are 0 and 14. So we got here this very point is the solution. The question is like this: the probability of getting head in a toss of a biased coin is 2/3. Let the coin be tossed 3 times independently, then the probability of getting head in the first 2 tosses and tail in the final toss is, the options are 4/27, 1/8, 2/27, or 23/27. Okay, so let's try to figure out what we are being given. We have a coin which is biased. Okay, that means our outcomes are not equally likely. Okay, and we are being told that probability of getting head is equal to 2/3. Okay, in a single toss. Therefore probability of getting tail will be equal to 1 minus 2/3. Okay, which comes out to be 1/3. So there are more chances that head will come out and less chances that tail will come out. Now this coin is being tossed 3 times. Okay, independently. We are being told what is the probability of getting head in first 2 tosses. Okay, so let us say if we have head tail. Okay, we are being told what is the probability that we get head, head and tail. That means we get head in the first toss, head in the first toss, second toss, and tail in the last toss. Okay, so what is the probability? That means probability of getting head in the first toss is equal to, let me write it here, probability of head into, again we have probability of head into probability of tail. Okay, probability of head is being what we got, that is 2 upon 3 into 2 upon 3 into probability of tail is 1 upon 3. So this is 2 to the 4, 3 3 are 9, 3 are 27. I guess 4 upon 27 should be the correct option. Okay, so here we don't have equally likely, we have a coin which is biased towards getting head here. Okay, so there are 66.666 chances that head will come out, and only 33.333% chances that tail will come out. Okay, by equally likely events, when we mean when the probability of getting head or tail is same, but here this is not the case. Okay, so an analyst at Green Car Store Limited estimated the following demand for the electric vehicles it sells. We have QE is equal to 0.75 minus 1.5 PE plus 2.5 PF minus 0.5 PB plus 3.2 I, where QE denotes the number of electric vehicles in thousand per year, PE denotes the unit price of electric vehicles in lakhs, PF denotes the average unit price of vehicles using fossil fuels, that is in lakhs, and PB denotes the unit price of battery used electric vehicle in lakh. I denotes the personal disposable income. Okay, we are being given the value of PE is 6.5 lakh, PF is 4.5 lakh, PB is 0.5 lakh, and I is equal to 10 lakh. Then income elasticity of demand and cross price elasticity of demand satisfy. So we have to find out the income elasticity of demand and cross elasticity of demand. Okay, so let us try to figure out. So we have this equation. Okay, this is our demand equation. I have written it here. So PE, the value of PE is 6.5 lakh, PF is 4.5 lakh, PB is 0.5 lakh, and income is 10 lakh. Okay, now income elasticity of demand, how do we calculate? Income elasticity of demand is simply dQE upon DI. That means the derivative of this demand function with respect to income into I upon QE. Okay, this is simple income elasticity of demand function. Now QE, what is QE? If we plug the value of PE, PF, PB, and I in this demand function QE, we will get the value of QE as 34. Okay, and what is the derivative? This very stuff here, dQE upon DI. dQE upon DI means the partial derivative of this demand function with respect to income. Okay, so since we have no I involved in these terms, so their derivative will be 0, and since only in the last term we have I, the derivative of I is 1, so we are left with 3.2. Okay, so I have written here dQE upon DI is equal to 3.2. Okay, then income elasticity of demand is equal to this dQ upon DI, okay, which we calculated as 3.2 into the value of I is being given as 10 lakh, so I had written here, and the value of QE which we calculated here 34. Okay, when we multiply 3.2 to 10 we get, and divided by 3.4 we get income elasticity of demand equal to 0.94. Okay, similarly we were told to find out the cross price elasticity of demand. The equation in this the formula will be same. That means change in quantity demanded upon change in the price of change in PF, that means this very stuff here, okay, into PF upon QE. Okay, so QE we calculated, this is 34, PF is being given us as 4.5 lakh. Okay, now DQ upon DF means we need to take the partial derivative of this demand function with respect to pf. Okay, so the since we have only one term where pf is involved, so derivative of pf is 1, so we are left with 2.5. so I have written here 2.5. Then cross price elasticity of demand will be equal to this dq upon df, which we calculated as 2.5, into the value of pf, which is 4.5, and QE, which we calculated earlier here, okay, which came out to be 34. When we multiply 2.5 with 4.5, we get cross price elasticity of demand equal to 0.33. Okay, so the options then will be, this very step, I guess. We calculated this was income elasticity of demand, which we calculated 0.33, sorry 0. We calculated cross price elasticity of demand is 0.94, and sorry, we calculated the income elasticity of demand is 0.94, and cross price elasticity of demand is 0.33. so the correct option should be D. The following table presents national income related aggregates at current prices for the year 2019-2020. We are told to find out the personal disposable income for the year 2019-20. Okay, so personal disposable income, let me write it here. Personal disposable income is simply equal to personal income, okay, minus household direct taxes. Okay, household direct taxes. Okay, our personal income is being given us as 140, so we can write 140 minus the household direct tax, that is 28. Okay, so when we subtract 28 from 140, we get 112 as the personal disposable income. Okay, all the other stuff that is being given here, like net factor, income earned abroad, or private income, GNP, NNP, this is only to confuse, okay, you people. Otherwise, if we subtract household direct tax from the personal income, we get personal disposable income. Next question is, the following table provides a list of countries selling Big Mac and market exchange rates in January 2019. We are being told to find out the cheapest price in US dollars of Big Mac. Okay, so we are being given country here, the price of Big Mac in local currency, and market exchange rate between local currency and US dollar. Okay, now let us see here. Here we can see in United States of America, the price of Big Mac is $5.58. Okay, and in Norway, what is the price of Big Mac in terms of US dollars? How do we find this? Simply we write the local price of Big Mac, that is 50 in case of Norway, and we divide it by the exchange rate between US dollar and krona. In this case, it is 8.53, which comes out to be 5.86. Okay, so the price of Big Mac in Norway in terms of US dollar is 5.86. Okay, similarly, we can find the price of Big Mac in terms of US dollars. Simply what we write the local currency. Okay, let us say we have Mexico, we write the local currency price, which is 49, and we divide it by the exchange rate between dollar and local currency, which is 17.31. Okay, and this will give us the price of Big Mac in terms of US dollar. Okay, but it is up to you to calculate all this stuff. The cheapest price of Big Mac in US dollars will be in Russia. Okay, so what will be the cheapest price? Simply we write the price in local currency, that is 110.17 rubles, 110.17 price in local currency, divided by the exchange rate between US dollar and local currency, that is 66.69, which gives us the price of Big Mac in terms of US dollars as 1.65. Okay, so cheapest value comes only in Russia, given this data here. Okay, so the answer to this question should be 1.65. Okay, so simple thing is, how do you find the price of Big Mac in this question in terms of US dollars? Just write the price in local currency. Okay, price in local currency, and divide it by the exchange rate. Okay, exchange rate, and this will give you the price in US dollar. Next question is, in a market, two firms F1 and F2 are producing homogeneous products. The demand function, that is inverse demand function, is being given as P is equal to 120 minus 0.5 Q1 plus Q2, where P is the unit price of the product and Q1 and Q2 are the outputs from the firms F1 and F2 respectively. Suppose cost functions of F1 and F2 are C1 is equal to 20 Q1 and C2 is equal to 10 plus 0.5 Q2 square respectively. Okay, these are the cost functions of the two firms. Then the total profit earned by both the firms, assuming perfect competitive market, is we need to find out the profit that these two firms will get. Okay, assuming we have perfectly competitive market. So what we are being given, we are being given the inverse demand function is 120 minus 0.5 Q1 plus Q2. This is the inverse demand function, and cost function for firm 1 is being given us as 20 Q1, and for second firm we are being given cost function is C2 is equal to 10 plus 0.5 Q2 square. Okay, so how do we solve this question? First, what we will do here, first we will find the total revenue for firm 1 and total revenue for firm 2 and marginal cost for firm 1 and marginal cost for firm 2. Okay, so let's calculate for firm 1. Let us say for F1, what will be the total revenue? Total revenue is simply price into output produced by firm 1. Okay, so which means our total revenue will be equal to, P is being given as this very function, so I will write 120 minus 0.5. If I multiply this, so this will become Q1, then we have minus 0.5 Q2. This is our P, to this we multiply Q1. Okay, so we will get here 120. Now multiplying this Q1 to each of these terms, so this is Q1 minus 0.5. Q1 into Q1 is Q1 square minus 0.5 Q1 Q2. Okay, this is the total revenue for firm 1. Okay, we know the equilibrium condition is our marginal revenue should be equal to marginal cost. Okay, so marginal revenue for firm 1 should be equal to the marginal cost for firm 1. So we got the total revenue. Now we need to find out the marginal revenue. So let us denote TR1 is the total revenue for firm 1. So marginal revenue for firm 1 is simply the partial derivative of total revenue function of firm 1 with respect to Q1. Okay, so just partially differentiating this function with respect to Q1 will give us the marginal revenue for firm 1. So the derivative of Q1 is 1, so we are left with 120. Derivative of Q1 square is 2 Q1, so 2 into 0.5 is 1, so we are left with Q1. Okay, this is from the power function rule of differentiation. minus here the derivative of Q1 is 1, so we are left with 0.5 Q2. Okay, this is the marginal revenue for firm 1. Now what is the marginal cost for firm 1? So marginal cost for firm 1 will be simply the derivative of cost function of firm 1 with respect to Q1. Okay, what is our total cost? Total cost is being given by this very function. Now taking derivative of this function with respect to Q1, so derivative of Q1 is 1, we are left with 20. Okay, so at equilibrium our marginal revenue should be equal to marginal cost. So at equilibrium marginal revenue of firm 1 should be equal to the marginal cost of firm 1, which implies marginal revenue is 120 minus Q1 minus 0.5 Q2, and we equate it with the marginal cost, that is 20. Okay, now if we arrange this, we can write it like this. So we have here, if I transpose this here, so this becomes, or let me transpose these terms on RHS, so they will become positive. So we have Q1 plus 0.5 Q2 is equal to 120 minus 20 comes out to be 100. Okay, I hope I am making sense here. So this is the equation for firm 1, and similarly using same procedure, let's find out the total revenue for firm 2. Okay, firm 2 total revenue. So total revenue for firm 2 will be simply P into quantity produced by firm 2, and P is being given as this very function. So we have 120 minus 0.5 Q1 minus 0.5 Q2. Okay, so I'm just multiplying this Q.5 to each of these terms. This is total revenue for firm 1. Then marginal revenue for firm 2 will be simply the partial derivative of total revenue of second firm with respect to quantity produced, that is Q2. So taking partial derivative of this function, derivative, we have to multiply this very function with Q2 first. Okay, so we will get here 120 Q2 minus 0.5 Q1 into Q2 minus 0.5 Q2 square. Okay, now taking this is our total revenue for firm second. Then marginal revenue will be the derivative of this very function with respect to Q2. Derivative of Q2 is 1, so we are left with 120 minus derivative of Q2 is here 1, so we are left with 0.5 Q1, and derivative of Q2 square is 2 Q2, so 2 into 0.5 comes out to be Q2 only, so we have Q2. This is the marginal revenue for firm second. Now equilibrium requires our, so let's calculate first marginal cost for firm second. Marginal cost for firm second is simply the derivative of cost function of firm second with respect to output, that is Q2. So this is the cost function for firm second. Taking partial derivative with respect to Q2 gives us marginal cost. Derivative of constant is 0. Now derivative of Q2 square is 2 Q2, so 2 into 0.5 is 1, so we are left with Q2 only. Oh, this is the marginal cost for firm 2. Now using equilibrium condition, that is marginal revenue for firm second should be equal to the marginal cost for firm second. This is the marginal revenue for firm second, 120 minus 0.5 Q1 minus Q2, and we equate it with the marginal cost of firm second, that is Q2. Okay, when we solve this comes out to be, so what we can do here, if I transpose these terms to RHS. Okay, so this will become Q2. Then we have, so let us do one thing here. I can do one thing here. If I transpose these terms, so we have 0.5 Q1. Okay, when I transpose this to RHS, so Q2 plus Q2 will become 2Q2, 2Q2, okay, is equal to 120. Okay, so we have two equations, this equation for firm first and this equation, so sorry, this is for the firm second and this is for firm one. Now to get the optimal values of Q1 and Q2, we will solve these two equations. Okay, let me see if I have the space here to solve this. So let's write it here. So we have Q1 plus 0.5 Q2 is equal to 100, and we have this 0.5 Q1 plus 2Q2 is equal to 120. Okay, let us try to solve these system of equations here. So what we need to do, we need to make the coefficient of either Q1 or Q2 same in both equations. Okay, so if I multiply this equation with 2, okay, if I multiply this equation by 2, so the equation will become 2 into 0.5 comes out to be Q1. Okay, now 2 into 2 is 4 Q2 is equal to 120 into 2 is 240. Okay, so now let us, we have this equation and this equation. Okay, my endeavor was to make either the coefficient of Q1 and Q1 or Q2 same in both equations. So I just make the coefficient of Q1 in the second equation same as that of Q1. Okay, by multiplying both sides by 2. Now we can subtract these two equations. Okay, if I subtract, what we are being left, so this will become, this is minus, this is also minus, this is also minus, so Q1 minus Q1 is, they will get cancelled. So we have 0.5 Q2 minus minus 4 Q2. So we have actually, so let us see what is 4.00 minus 0.5. so if we subtract, 10 5 0.3, so we are left with minus 3 Q2 is equal to 100 minus 240 comes out to be so we are left with 140 here. Okay, minus 140, so minus minus gets cancelled. So we have, am I doing the calculation right or not? 240 so we have here 3.5. okay, I am really sorry for these small mistakes here. 3.5 actually we have, so which implies Q2 will be equal to 140 upon 3.5. okay, 3.5 if we divide it by, so what will come out? Actually I have not solved this question. So we have 140 upon, so 3.5 can be written like this, 35 upon 10. So we have 140 upon 1 into 10 into 35. So we have 5 7 5s are 35, 7 2s are 14. So we have 20 here, 5 1s are 5 2s are 10, 20 into 2 is 40. So I guess Q2 should be equal to 40. So we got the value of Q2 is 40. Now just plug Q2 is equal to 40 in what equation? Let us put here the value of Q2. That means Q1 plus 0.5 into 40 should be equal to 100, which gives us Q1 is equal to 100. 0.5 into 40 is 20, that is 100 minus 20 comes out to be, am I doing the calculation right here? So we have 100 minus 20, obviously 100 minus 20 is 80. That means optimal value of Q1 comes out to be 80. Okay, so we got Q1 and Q2. Now just plug these values into the market demand function. Okay, so I have no option but to rub so let me rub this out here. Okay, so just plug the value of Q1 and Q2 into market demand function. That gives us P is equal to 120 minus 0.5. Q1 and Q2 is 80 plus 40. So I will write here 80 plus 40. So this is 120 minus 1 half of, or sorry, but that is 120. So this is 260s are 120 minus 60 comes out to be 60. That means prices will be, price will be 60. Okay, now what will be the total profit earned by both firms? So total profit earned by both firms will be equal to total revenue, that is price into quantity produced by firm 1 plus price into quantity produced by firm 2, okay, minus cost of firm 1, that is 20 Q1, minus cost of firm second, that is 10 minus 0.5 Q2 square. Okay, when we subtract the total costs of firm 1 and 2 from their total revenue, we will get the aggregate total profit. Okay, so pi will be equal to, now what is P and Q? We calculated P is 60, Q1 is 80. So we have 60 into 80 plus again 60 into 40, P into Q2, okay, minus 20, Q1 is 80. Okay, then we have minus 10 minus 0.5, I will write it like this. Then we have Q2 square, that means 40 into 40 square. Okay, so this is 40 square. Okay, so let's try to figure out what will it come. So let me write here. Okay, so this is 4800 48, so 4800 plus 6 for the, this is 2400. Okay, minus this is 8 2s are 16, this is 1600 minus 10 minus 1 half of 1600. Okay, so this will come out to be, let us do the calculation here. So we have here 0 0, so 0 0 we have 2 here, so 7200. Then we have here 800. Okay, so this is 2400 minus 800 minus 1600 comes out to be minus 2400. So we have 2400. To this, if we subtract 10, this will come out to be 2390. Okay, so we have 2390. Okay, if we subtract these two, so 0 goes 0, so we have here actually I have not solved it earlier, so I'm not able to do this basic stuff here. So 6. Okay, no, we don't have 9 here, we have 10 minus 3, this is 7 Okay, then we have 6 minus 2, which comes out to be 4. Okay, I guess this should be the answer to this question. I am not sure whether the calculation is right, but the process is very much same here. Okay, so just calculate the total revenue of both the firms, then calculate marginal revenue of the both firms, and also calculate the marginal cost of the both firms. Then use the equilibrium condition, that is marginal revenue of firm 1 should be equal to marginal cost of the firm 1, and then we can find out the profit function. Next question is, ACD Bank holds a total deposit of 2,56,412 to expand money supply in the economy during the COVID-19 pandemic period. The Reserve Bank of India reduces the cash reserve ratio from 4.5% to 3.5%. Due to this policy change, the additional money supply generated by ACD Bank is, we have to find out the increase in the money supply when CRRP is being reduced from 4.5% to 3.5%. Okay, so let us see. So what we are being given, total deposits that is being given as is 25, that is 2,56,412. Originally our CRR is 4.5%, which can be written as 0.045 if we write them in decimals. Okay, then money supply that will be generated will be equal to the money multiplier times the total deposits. Okay, money multiplier is being given by 1 upon CRR, okay, 1 upon cash reserve ratio times the total deposit. Okay, so when we multiply this, we have 1 upon 0.05 to the initial deposits, we get this very figure here, that is 10,000 lakh 10 lakh. We get 56 lakh 98,044 rupees that will be generated if CRR is 4.5% and initial total deposits are 2,56,412. Okay, now RBI has reduced the CRR to 3.5%, which can be written as 0.035. Then new money supply will be equal to money multiplier times the total deposits. Money multiplier is simply 1 upon CRR, that means 1 upon 0.035 times the total deposits. Okay, so when we multiply this money multiplier with total deposits, we get a figure of this 73 lakh or 26,057. Okay, so this is the new money supply when CRR was 3.5%. This is the old money supply when CRR was 4.5%. Now money supply generated will be equal to new money supply, this figure, minus old money supply, that means this figure. When we subtract these two figures, we get 16,28,013 as the additional money supply generated when CRR is being reduced from 4.5 to 3.5. This monthly per capita consumption expenditure of 10 households in a region is given by, we are being given the monthly per capita consumption expenditure of 10 individuals here, H1, H2 up to H10. Okay, assuming poverty cutoff, what we call poverty line, of monthly per capita consumption expenditure to be 2,000 rupees, that means poverty line is 2,000. The scared poverty gap ratio is, we have to find out the scared poverty gap ratio. Okay, how do we find the scared poverty gap? It is simply as we calculate the poverty gap ratio, as I have explained it in earlier video. So I will put the link of that very video also in the description box here. So the formula is simple. We have 1 upon n, okay, a summation of C less than Z to Q, okay, then we have Z minus C upon Z. Okay, now what does this mean? N denotes, N is the total population. In this case it is equal to 10. We have 10 individuals. Okay, Q denotes the number of poor, and how do we know the number of poor. Number of poor are those people whose income is less than 2000, to be precise, whose monthly per capita consumption expenditure is less than 2000. Okay, that means number of poor in this case. And Z denotes our poverty line. Okay, what is here written as poverty cutoff, POVER, poverty cutoff. Okay, and C denotes the consumption expenditure, uh, consumption expenditure of the poor people. Okay, now using that very stuff here, we can calculate the squared poverty gap will be equal to, so we have 1 upon n, that means 1 upon 10. Okay, then summation of C is less than Z to Q, that means firstly if I write it like this, so our Z is equal to 2000. Now C denotes the consumption expenditure of the poor people, and poor people are those whose monthly per capita consumption expenditure is less than 2000. So which of the values that we need to take here? Any value which is less than 2000 will be the poor here, that means C. So we have 2800, it is greater than, this is also greater than 2000, so we have 1200, we have 1400, we have 1000, we have 900, we have 1300. Okay, these will be the value of C's. Okay, so we have Z is 2000, so we can write it like this. So in place of Z I can write 2000 minus then we have 1200 upon 2000. Okay, and we have to square it, plus taking another value, Z is same, 2000 minus what is another number, that is 1400. 1400 upon the value of Z is 2000, and we need to square it, plus then we have this 1000. Okay, so let me write here 2000 minus 1000 upon 2000, squaring this out also, plus we have this 900, so we have 2000 minus 900 upon 2000, squaring again this also, and lastly we have this 1300, that means 2000 minus 1300 upon 2000. Okay, I hope I am making myself clear. So how do we calculate? We write 1 upon n and take the summation of this Z minus C Z. So we have obviously square here, I forgot to write it here, and C denotes the number of persons whose consumption is less than Z, that means whose consumption expenditure is less than 2000. Okay, just taking the squares, adding them up obviously. So we have 1 upon 10. Okay, then we have now 2000 minus 1200 comes out to be 800, so we have 800 upon 2000 squared, plus 900 minus 1400, this comes out to be 600 upon 2000 squaring, plus we have 2000 minus 1000 comes out to be 1000 upon 2000 squared, plus we have 11,000 here, sorry 1100 here upon 2000 square, plus we have 2000 minus 1300, this comes out to be 7, I guess it is 700 upon 2000 squared. Okay, so we can take these two zeros here, so let me write it here. We have 1 upon 10, we are left with here 8 8s are 64, 64 upon 20 into 20 is 400. Okay, plus, so here if I cancel these two zeros, we have 6 6 are 36, we have 36 upon 20 into 20 is 400. Okay, I don't need to take these brackets here, plus, so let me use other color here. So I just cancel two zeros here, these two here, two zeros here. I will also cut the zeros. Okay, so what we are being left with, so we have 10 tens are is 100 upon 400 plus 11 11 is 1 to 1 पे कॉल कीजिए, we have 400 plus 7 7s are 49 upon 400. Okay, so this will come out to be, so which implies we have 1 upon 10. Now 49, 1 to 100, 36 and 64. This will come out to be, I have calculated it, this comes out to be 370 upon 400. So cancelling these two, we are left with 37 upon 400, which gives us, if we solve this, will come out to be 0.093. So our what we call scalar poverty gap ratio is 0.093. okay, and we also say this as the severity index. Okay, poverty severity index, it gives us the weighted sum of poverty gaps as a proportion of the property line, and we call it also the poverty severity index. If in place of this we have 1, this is the formula for poverty gap ratio. If it is here 2, then it is the scalar poverty gap ratio. If it is 0 here, then we have head count ratio. Okay, so this only depends what is the exponent of this very stuff here. Okay, I hope I make myself clear here. Thank you.